Good evening to one and all present here. My name is Divya Kumar, Assistant Professor from SNS College of Technology. In this video lecture series, we are going to discuss about the design of brakes in the subject design of transmission system. What is a brake? First, we are going to discuss about an introduction of brake. A brake is a mechanical device which is used to slow down or stop the motion of the moving machine or vehicle by converting kinetic energy into a heat energy through friction. Brakes are one of the most important safety components in automobiles, industrial machines, elevators, cranes and railway systems. The major functions of brakes are: it reduces the vehicle speed, it stops moving systems safely, control the motion during the descending, and also it holds the vehicle in stationary position, prevents accident and overload motion. The principles of braking are: brakes works on the principle of friction. When a stationary brake lining comes into contact with the rotating drum or disc, frictional force is produced. This friction opposes motion and converts kinetic energy into an heat energy. There is a formula for the frictional force, F, which is equal to mu into N, where F is the frictional force, mu is the coefficient of friction, and N is the normal reaction force. And also there is a formula for the braking torque, TB, which is equal to F into R, where TB is the braking torque and R is the radius of brake drum or disc. Next, we are going to discuss about the different types of brakes. According to the method of actuation, there are about major three different types: mechanical brakes, hydraulic brakes, pneumatic brakes, and also electromagnetic brakes. In case of mechanical brake, it is operated using levers and rods, whereas in case of hydraulic brakes, here it uses brake fluid pressure. It is majorly common in automobiles. Next one is the pneumatic brakes. It is operated majorly using the compressed air, and the major application, it is majorly used in the heavy vehicles. Next one is the electromagnetic brakes, where it can be operated with the help of a magnetic force. It is majorly used in trains and elevators. Next important type is drum brake and disc brake. It is classified majorly based on its construction, whereas in the case of drum brake, brake shoes press against the rotating drum. There is an internal, it is one of the type of internal expanding type, whereas in the case of disc brake, brake pads squeeze the rotating disc. Better cooling and braking efficiency can be achieved in case of the disc brake. Next, there are about different types of mechanical brakes such as shoe brake, band brake, disc brake, internal expanding brake, etc. In case of shoe brake, there are about single shoe brake and also a double shoe brake. Likewise, in case of band brake, the simple band brake and also differential band brake. The construction of single shoe brake is: brake drum is attached to the rotating wheel, brake shoe moves with the friction lining, and the lever is used to apply the force. When force is applied to the lever, brake shoe presses against the rotating drum. Therefore, the friction is developed and the drum slows down and stops the moving vehicle. Next, we are going to discuss about the braking force analysis. The formula for the tangential braking force is Ft, which is equal to mu into Rn, where Ft is the tangential braking force, Rn is the normal reaction. And then the formula for the braking torque is Tb, which is equal to Ft into R. Next, we are going to discuss about the design of single shoe brakes. There are about different types of design parameters: braking torque, coefficient of friction, normal force, width of brake shoe, etc. There is a formula for the braking torque, Tb, which is equal to 9550 P divided by N, where P is the power in the kilowatt and N is the speed in RPM. The coefficient of friction, there are about two types: leather lining, the value of coefficient ranges from 0.25 to 0.3, whereas ferrado lining 0.3 to 0.4. Next, there are about self-energizing brakes and also self-locking brakes based upon the applications. We can use And finally, we need to consider heat dissipation, temperature rise, brake fading, thermal stress for designing the accurate and